So primarily our biggest test here is the heavyweight shock testing in accordance with the Navy mil spec, which is MIL DTL 901E. MIL DTL 901E is shipboard shock, and it's designed, the mil spec is designed to simulate a near-miss underwater explosion. So for the testing, the first part and the hardest part is developing the procedures. The procedures include test fixture designs, operational procedures. The procedure is reviewed by customers and then ultimately is sent to the U.S. Navy for approval. After Navy approval, we have a license to do the test. We've got to build the fixtures, install the equipment, install it on the barge to replicate the shipboard environment, and then we set off a series of underwater explosion charges around the barge. So we are testing the operation of the equipment. So we want to make sure that the equipment can continue to operate before, during, and after each shock event.
So for naval specifications, anything installed aboard a U.S. Navy vessel is subjected to mil-spec testing for it. The heavyweight shock platform, basically it's simulating the near-miss explosion of a ship at sea. So apparently the auspices of it come out of like World War II, where they had a lot of near-miss explosions, or if you've probably ever seen any of those World at War videos, they're strafing, dropping bombs next to destroyers, and you're getting this concussive shock wave. So they came about the shock hardening. So basically that's what that represents. And these decks are tuned to represent the installation aboard a Navy ship. So there's a different harmonic response based upon where it's installed on the ship.
Shock testing is the main thing, and we do heavyweight shock testing. We do lightweight shock testing, which is to simulate a hull test for smaller equipment items, approximately 250 pounds or less. And then behind me is what's called a deck simulating shock machine. That machine was developed on site here in conjunction with Newport News Shipbuilding, and it's designed to simulate the environment on a deck installed inside of one of the barges. It's a much more efficient way to conduct a shock test for shock isolated equipment that meets the weight requirements, which is approximately 2,500 pounds or less. So the extended floating shock platform, it has a capacity up to roughly 100,000 pounds, so more capacity is larger test items. Typically what it's used to test is lower frequency test items.
So primarily our biggest thing is the heavyweight shock testing is the the floating shock platforms. There's only 2 commercial facilities in the country, and us being one of them. We also have a dynamic shaker, a vibration table. We have the deck simulating shock machine, which there's only 3 of those in the country as well. So that's one of our big draws. We do have a temperature and humidity chamber, lightweight test machine, but those vehicles there's more of throughout the country. So the DSSM and the floating shock platforms, heavyweight shock testing, pretty much sets us apart.
Well, first off, we do what is called like a kickoff email, and that's basically introducing ourselves and who's going to be their team here. Then we require, or we ask them to come up with a date that would be available for an actual meet and greet, usually via Teams. And from there, I'm just going to basically ask you, any information. We pour over the drawings, our engineers pour over the drawings and the information on the EUTs, or the equipment under test. And then we're going to just kind of start a development process. And the time when we're developing the test procedure and the test fixture drawings with the engineers and the draftsmen and the technicians here.
The testing we conduct here ensures our sailors operate in a safer environment. Sailors leave port, we take it for granted they're coming back. There's no guarantee. The environment sailors are operating in today are they're more and more dangerous every day. Read the news. And it's important to have a robust warship that can withstand those threats.